Hello, everyone. Welcome to another episode of the Engineering Student Experience Podcast. I'm Paul Nissenson from the Mechanical Engineering Department at Cal Poly Pomona. Back in episode 25, I interviewed Simi Mehrabani, who's an engineer at my local air quality regulatory agency called the South Coast AQMD. One of that agency's primary responsibilities is to develop rules that limit the emissions of air pollutants for the health and safety of the over 15 million people who live in that district. The South Coast AQMD issues permits to businesses who have the potential to emit a certain amount of pollutants into the air, and CME in particular is part of a team that issues permits to businesses that have coating and printing operations. In order to receive a permit, a business must demonstrate to the regulatory agency that they have a plan to reduce emissions of air pollutants to acceptable levels, and this plan must be backed up with the appropriate engineering calculations. The equipment that reduces air pollutants must be carefully selected to minimize the initial capital costs, the ongoing operational costs, and they must target the specific compounds that are being emitted by the business. For example, a business that has printing operations likely will emit significant levels of volatile organic compounds, also called VOCs, due to the evaporation of ink. VOCs may be toxic on their own in high enough concentrations, or they may contribute to the formation of other pollutants, such as ozone, which is really important here in Southern California. There are several options for reducing VOC emissions from a printing operation, and the best option will depend on the amount of VOCs generated each day, how many hours per day the business is operating, the combustion properties of the VOCs, and, well, many other factors. Most business owners are experts in their particular field and understand the business side of their operations, but most business owners are not engineers and don't have the technical expertise to develop a plan to reduce the emissions of air pollutants. So, most business owners must turn to engineers who are experts at air pollution control, or also called air pollution abatement. Joining me today to discuss how engineers help businesses comply with local air pollution regulations are Anoosheh Oskouian and John von Bargen from Ship and Shore Environmental, a company that specializes in the design and construction of air pollution abatement systems. Anoosheh is president and CEO of the company, and John von Bargen is the vice president and director of engineering. Both have decades of experience in this field of air pollution abatement. I first met Anoosheh and John about 7 years ago, and every year when I teach my senior level course on air pollution, I take my students on a field trip to Ship and Shore's facilities in Signal Hill, California, so they can see firsthand how the concepts learned in the classroom actually apply to the real world. Anoosheh and John have always been very welcoming and love sharing their knowledge with the next generation of engineers, and so I thought it would actually be really great to record this episode with them. During the interview, Anoosheh and John discuss why the field of air pollution abatement is really important in our everyday lives. They discuss how Ship and Shore Environmental works with businesses and local air quality regulatory agencies to help meet the air pollution abatement needs of those businesses. They also discuss the types of engineers who typically work in this field, the history of air pollution control in the US, and many other topics. Now, before we get to the interview, I just want to mention that I recorded this episode in John's office at Ship and Shore Environmental. Like any company, there's a lot of activity going on, and sometimes you'll hear some background noise. Although I think I was able to clean up most of it in post-production. Also, if you make it to the end of the interview, you'll notice the interview ends a bit abruptly. We recorded this episode during business hours, and Anoosheh and John understandably had to take a call with a customer. I was just happy to get an hour of their time. And now let's hear from Anoosheh Oskouian and John von Bargen from Ship and Shore Environmental. I hope you enjoy the conversation. Well, I am here at Ship and Shore Environmental, a company based in Signal Hill, California. And today we're going to talk all about the field of air pollution control or air pollution abatement. And I have sitting across from me on my left, I have John von Bargen, who is the Vice President and Director of Engineering at Ship and Shore. And on my right, I have Anoosheh Oskouian, who is the President and CEO of the company. Welcome to you both.
Thank you.
Thank
It's
you.
lovely to be here with you.
Well, I've been really looking forward to this episode because my research background long time ago when I was in graduate school and as a postdoc was doing computer modeling of atmospheric systems. But I didn't really get much exposure to the control side of things. So how do we actually reduce the air pollution? I learned a lot about air pollution formation, but not the control side. So anytime I can talk to anyone who's an expert in those fields, I really love it. Before we get into that, though, I think it'd be really helpful for the listeners to get some background information about you both. So can you remember when you first started getting interested in engineering, and what was your, let's say, your educational background to prepare you for this field?
Thank you for the opportunity, and I'd love to share some personal experiences as well as what could be eventually beneficial to a lot of the listeners. I became very interested from early days in high school, junior high school, where I became fascinated with chemistry and the dynamics of chemistry. I realized that so much in the world that we live in relies on it. And the sense of coming up with solutions, I did not know what solutions I was looking for, but the making of the things and all that there was about it fascinated me. So I knew and realized that I would eventually have to go to something technical to fulfill the questions in my head and the love of chemistry and formulas and numbers and math and sciences. So that was one of the first times I could remember, and it was all owed to a wonderful chemistry teacher I had at an early age.
And where did you go to for your advanced studies?
I have migrated to this country. I'm originally from Iran. I came to Colorado to finish my high school. So I did a couple of years of high school there and eventually University of Colorado. And that's where I took up chemical engineering and continued with it with the hope of eventually being able to work as a chemical engineer.
And how about you, John?
I grew up in a small city in the middle of the jungle, in a oil refinery city. It was owned by Standard Oil. My father worked in Standard Oil. And I was always, interested to see what was working there in that refinery and the tankers coming in. And I had an uncle that was an engineer, was a chief engineer on a tanker. And I always liked the idea of being an engineer. And I was, at that time, I was about 13 years old. So this is a more little political story where Indonesia became a country because it was a Dutch colony at one time. And so we were all thrown out of Indonesia. My father sent me before him to Holland. And in Holland I went to I graduated high school and I went to the Merchant Marine Academy. And then I started working for Esso, Standard Oil, of course. And I was put on new ships, and we were building new supertankers in those days. So I spent a lot of time testing the ship itself, what it would do. So they put me 6 months on the shipyard and 6 months on the ship. And from there, I immigrated to the US because I did not like Holland. I didn't like the weather and all of that. And I came here and I worked at Loyola University, which is now Loyola Marymount. And I was in charge of maintenance and later on of the whole physical plant. So I took care of everything, construction as well as maintenance, security, and you name it, it was under me. But while I was there, I studied chemical engineering. So I did that for about 7 years. And then I joined one of the regents of the university that started a company in air pollution. And so here I am in the air pollution field, 1971.
Probably many listeners don't know anything about this field of air pollution control or air pollution abatement. How would you describe this field, And could you explain why you feel it's a really important field to be in?
True, many people are not aware that really should be aware that everything we do and everything we make and every manufacturing facility that is potentially processing any chemicals, making any plastics, making products that would be used for pharmaceuticals, for just about anything that we come in contact with. The process of making it and manufacturing it is wonderful, are things that we need. However, as a result, we are constantly working with various chemicals that in the process are constantly emitting emissions, or what we refer to as volatile organic compounds, VOCs, that are just sent out to the atmosphere. For years and years, I believe manufacturers were very concerned with running their businesses and not necessarily thinking about the aftermath of what they're doing to the atmosphere, what they're doing to the neighborhoods that they're around. And the emissions became a major problem. And I usually refer to this, as we are here in Southern California, the LA basin. For years and years that you flew in, you could not see 5 feet in front of you because of the existence of all the pollution and the smog, and that yellow haze was a combination of all that there was in the air. Therefore, I believe the entities locally, especially in Southern California, that is very aggressive about making sure that emissions are taken care of and are handled, and companies that are producing these emissions have a plan as to how do they handle it, how do they control it, how do they get rid of it, and it's something that we all walk around nowadays, enjoy cleaner air, and we're able to see our blue skies, but many of younger students may not remember the days that things were just really bad. And if they wanted to take a look at it, as a comparison, this is what China looks like, which they are making a lot of headways now, developing rules and regulations, but this is how bad some of the industrial cities and major manufacturing sites in the US were like.
Yeah, both my parents grew up in Southern California, and so I got to hear a lot of stories about, especially from my mom, who grew up in La Crescenta, just a little north of Los Angeles, and she'd say there'd be some days where it would just hurt to breathe. You go outside and lots of irritation on all the mucous membranes, and they would cancel PE and
absolutely.
And, yeah.
Yep, there were a lot of days, and at one point in time, I don't think they necessarily had the solutions, but they would declare just bad air quality days, or they actually just walked outside and was extremely hard to breathe. So they started looking into this more and more. And I believe, I do not know and do not recall the formation of EPA, which overlooks everything in the country, Environmental Protection Agency. But I believe the need became after we became a much more industrial country, and nothing at all against manufacturing and having a robust industry. But as long as we take care of all that we create and all the harm we bring on the planet Earth, with having to fulfill the needs of so many people that need various products and all that there is.
Yeah, one time I got a chance to go on a tour of the South Coast Air Quality Management District, which is our local regulatory agency. And they made a point that always resonated with me is, if you don't like the local water, you can just go buy bottled water. But if you don't like the air, well, I guess you could buy, if you're inside your house, you could filter the air. But if you're going outside, you don't really have any choice. So we all have to deal with the air that's around us.
That's right.
So earlier, John mentioned how he got into the field of air pollution control. So how did you get involved in this area?
Well, I have to say I owe that to John. I was doing a lot of my engineering work with Fluor Daniel, Fluor Corporation, for a number of years. And that's where I was a chemical engineer and process engineer that worked at the company, and for various projects, number of different opportunities, and all different types of design and plants. Then I did some project work, and I eventually was given an opportunity to work on a project which I did not really want to. And I had moral issues as well as not wanting to move from California. And I had ran into John by way of someone that was speaking to me about him. And I was contemplating remaining at Fleur Daniel or not. So I eventually had a chance to meet him. So John and I had the opportunity of meeting, and after a while, when I left Fleur Daniel, I had started working with him, which we will leave the name of the company out of it. And John was the VP of engineering and had started that company on air pollution control and various types of equipment, due to the fact, and I'm speaking on behalf of John, but he was the VP of engineering for a major company called Hurt Combustion Engineers, who was one of the first companies and pioneers in building pollution control systems here. So I found the field very fulfilling, and I liked the idea of going into the environmental work and wanting to make best use of the engineering degree, yet putting it into better use, in my opinion. And that was how I learned more and more about pollution control and abatement systems and the applied engineering practices that I had sort of shifted from building nuclear plants and other things at Fluor over to the environmental side.
Yes. How many years total have you been in this air pollution abatement field?
We have been together since 1995 at this location.
Okay.
And we worked together probably about a year or so prior to that elsewhere. So we're just coming across 28 years.
Yep.
And I believe that may be something that will be mentioned or not, but John and I were co-founders of the company Ship and Shore Environmental in year 2000.
Okay.
So we have been Ship and Shore Environmental here at this location since year 2000.
Okay. And John, what year was it when you first started in this field?
1971.
Okay. So we just had the 50-year anniversary last year.
50-year anniversary.
Yes.
That's right.
And later on, we'll talk a little bit about you've had a front row seat to almost the entire history of air pollution control in Southern
Yes.
California. So later on, I'm going to love to hear your experiences. So you both are leaders in this organization, Ship and Shore Environmental. Can you provide an overview of what the company does? What kind of products does it produce? What kind of services does it provide? And what kind of engineers work here?
What we did, and that was one of the goals of us moving into this arena, with the mindset that we should always try to design solutions around the pollution problem that any facility may have. Therefore, we stayed very true and open to custom designing systems for what the application may be. And John has always used the statement, and I quote him at times, we're not married to one technology. We realize that there must be different ways of capturing and controlling, and we cannot be tied into one particular product, because then at that time we will become just product salespeople rather than solution providers. And that's one thing that I am very proud of that we do at Ship and Shore, with the mindset that I shared, John brought to the table, that we should be able to design different types of products for different applications. Not every single chemical and every single VOC that is out in the atmosphere can be destructed and destroyed the same way. Even though at the end of the day, what we have, VOCs have heating values. We want to capture as much of it as possible and try to have it go through our systems, various types of systems, whatever that may be most economical and feasible, depending on what the applications are. Naturally, a system that we would design for the emissions from a reactor would be controlled and designed differently than a printing facility that has a very steady stream of VOCs coming off from the process. Because of that, we thought that it would be great for us to have all different disciplines of engineering here in-house. We did start with naturally process and chemical engineers, as we both are, and then we naturally needed a mechanical to be able to get that work done. And then we realized we also have to have electrical and controls. So in summary, we have all disciplines of engineering in-house in order to be able to design a product that is suitable to address the needs. So all different disciplines of chemical, mechanical, electrical, even structural. Naturally, in California, we are governed by the most strict seismic rules and regulations. So we adopted that for all of the systems we do around. And at the beginning, our goal was everything that we designed to be built right here, because we had joined a company that was a manufacturing facility with the hope of bringing engineering disciplines and engineering know-how and technology to be fabricated and manufactured here. So the idea grew and became an overall concept that we built upon to be able to go to different industries. There were a number of industries we were very strong in, and then we actually expanded to various industries. And any area in the country that is governed by the most strict rules and regulations as far as the available tons of VOCs that you could send out to the atmosphere is where we do most of our work. And naturally, everything in between West Coast and East Coast. But West Coast is very strict. East Coast is the same way, New York, New Jersey, all of that area. And whichever state that you can think of that has a lot of manufacturing. Ohio is that way. Texas, definitely, because there's just a lot of industry, oil and gas. So oil and gas, as well as other ones, naturally are the driving force behind how we set up the company to be able to service them.
So right now we are recording this episode inside the office space of Ship and Shore Environmental. If you were to take me on a tour of your entire facility here, through the office spaces, to the big yard you have in the back, what would I see? What would I hear? Describe the space to the listener, and also if you could discuss where you'd see engineers working.
Well, of course, when you come in, you start at the lobby, and then you will actually pass the CEO's office and then the COO office, and then you'll come into the engineering space. This is all downstairs. We are a two-story building. Our second story has, in one office is sales, and the other office is accounting, and everything has to do with accounting. On the bottom floor is where the engineers are. We have all the engineers sitting, and the engineers are all the project managers, project engineers, as well as the designers and the draftsmen. And then on the back part is the people that take care of the operations and purchasing and material. When you come to the backyard, is the very first thing that you see is the equipment, where we have a computerized system that actually cuts sheet metal into the different shapes that we need for the air pollution system. And then also the ones that bend it and cut it. And then coming into the backyard, since this is California, we do a lot of stuff in the open spaces that you cannot do in Texas or in back east, where they have everything covered. So that's where we assemble actually the systems, the design systems, all the things that have been cut. They're assembled and then they're being welded. And then you will see all the welders working, and then you will see the part working where they actually put together the valving, the valve systems, and also the insulation, because we built a lot of incinerators, the thermal oxidizers and the regenerative thermal oxidizers. They're all operating at 1500 degrees, going up all the way to 2000. So it has to be insulated, because otherwise you're going to burn your metal down. So you will see how the insulation is done. And then in the back of the yard, you'll see our paint spray facility where the units are painted. And coming back forward, you will also have an area where we do the piping of all the for the burners as well as the gas piping, and build more the smaller parts that are being assembled. Things like dampers, filters that are being that all part of your of a whole system. And then in the end, on the side, is that you will see the systems that are being assembled, and then of course finished, and then going out of the yard.
So at this moment, what is the largest piece of air pollution control equipment you have being built in the yard at the moment?
If you look at it in cubic feet per minute, it would be is about 80,000 SCFM, standard cubic feet per minute. A unit like that is it's a good 3-story building height. And it's probably about, in length, at least 50 feet by about 15 feet in width.
Yeah, I've had the opportunity to see in the past some of the very large thermal oxidizers being transported away, and they're put on this flatbed truck, and it looks like it's quite heavy and quite large.
It is,
I'm sure you have to plan out exactly which freeways you're allowed to go under or go through to make sure you don't destroy the overpasses.
Yeah, see, and when we design these, we have to design what you call these sub-assemblies, so that you can put it on a truck, so that you can, the weight is where the roads can take it. And yes, it is something that has to be thought of. It is not like doing a washing machine or something like that.
What is a typical week like for both of you here at Ship and Shore? And it's probably different, I'd imagine, than some of the engineers that you have here. So what's a typical week like for some of the engineers that you have working for you?
I would imagine with the engineers, most of our engineers are assigned to a project or 2 or 3. Therefore, they are the project managers on the projects that we will be handling. They go through the design phase, they go through peer reviews. Then we do have a team here that does the procurement for all the equipment and instrumentation and everything that has to be manufactured here on site. So a typical week could be checking on the progress of where their project stands, a lot of communication with various clients or their own client to make sure that all that has been submitted to them has been reviewed. There are some projects that are extremely important for us to perform HAZOPs, which means that the client team members as well as our team members come together to review the what ifs in projects. Okay. And some projects are very straightforward. They don't go through that cycle, which is extremely high demanding on the engineer's time. So depending on the nature of the project and nature of the client and involvement, whether we're also doing their permitting for them, because we do process a lot of their permits as far as the air quality permit will go. And at times we support them with their local city permits. So it varies from project to project, but most of the time they literally are looking after the design and working with the client to make sure that they're making progress towards finalizing the design, then taking it to the manufacturer and overseeing their project. And one thing we do, which is a little different than some other entities perhaps, we have always been also known to do everything from A to Z, meaning that the project comes in, we do the permitting, we do the assessment, we even do some measurement and testing to verify what is there. The engineering phase is done, then we go into manufacturing, and we actually have a team that eventually travels with the unit wherever it goes or the system goes, and they oversee the installation either with local people or our own experts if need be, and go into complete startup of the unit. So because of that, a lot of people like the idea of having one entity that they work with rather than having to change hands between various contractors, and that's been a key to our success in many ways.
So I'd like to throw a scenario at you. Let's say that I want to open a factory that is going to manufacture styrofoam coolers. So there's going to be some plastics involved, there's going to be some styrofoam, all of which might have emissions involved. And I know about the business side of things, but I don't know anything about the air, pollution reduction side of things. So I call up Ship and Shore Environmental. What happens next?
Well, in Ship and Shore Environmental, so many times what we do is we say, well, on the air pollution side, we know quite a bit about your type of a process. So one of the things that we would like to know is we usually ask, what is the future? Not what you're doing exactly, what are you going to do 5 years from now? So when you start building and designing air pollution equipment, that's what you would like to ask for, a permit for that time. Because then the permit, you get it today. And if they change the rules, you are what they call grandfathered in. So this is basically what we do. So if somebody comes in there, then we have to ask them, okay, in all the different type of your process. And if you want to build an EPS, if you want to build coolers, what you need to do, you have to buy expandable polystyrene. You have to, with the expandable polystyrene, you have to pre-expanders. So what you have to do, you have to take the expandable polystyrene, they are coming into little beads. The beads are about 1/16 to 1/8 of an inch in diameter, and they are filled with pentane. About any place between 4 and 6% would be pentane. So that would be, if you have 100 pounds of pentane, you would have 100 pounds of expandable polystyrene. 4 to 6 pounds of it would be pentane. This has to be brought into a pre-expander, where they're going to expand this into a bead that becomes a certain weight that they want. If they say we're going to build a polystyrene cooler, now we want to do that with 1 pound per cubic foot expanded polystyrene. So the pre-expander will expand it to 1 pound per cubic foot. And then the other thing is, when that happens, usually in the pre-expander, any place between 18 to 25% of the of the pentane, the 4% pentane, is emitted to atmosphere. But that is emitted to atmosphere with steam, because steam is used to pre-expand. So that steam and pentane has to be captured.
Probably most listeners haven't heard of pentane. Why is pentane?
Pentane is it's a C5H12 though.
What is its? So it's in high enough concentrations, it's toxic to people, right? And it's also
yes. Well, yeah. One of the things is that pentane is that they for an 8-hour exposure it could be 1,000 ppm. So when people work in an area, They like to have it more down to about 600 ppm. Because otherwise what happens, you get dizzy. It is like a narcotic. So from the pre-expander, it is run into a fluid bed dryer, where the pentane beads are dried. And from the pentane beads are dried, they're put into an aging process. And the aging process is are actually big silos. And the silos are actually made of perforated, it is almost like mosquito screen, but these are of course from plastic. So they sit in there up to 24 hours. And during the 24 hours, they lose pentane. They can lose up to 30% of the pentane. So we already, let's take it at the maximum, we lost 25% at the pre-expander. Now we lose another 30%. Here's already 55% of the pentane that is being emitted. Then from there it goes into the cooler block, the molds, the shape mold, what they call, when they shape it into a cooler. And at the shape mold, there you lose about 16% of the pentane. And then the coolers are ready. They are put into a storage area. And many times, because even when you in the shape molds, they use steam. So they put it in a storage area to dry, basically, to get all the water out. And that's also what's called the hot room. So also pentane comes out of there. It's about 11%. So, and then about 15% remains in the product. So that goes out. So theoretically, the 85% is taken into atmosphere. But now to capture this and do this, basically you could only really capture about 80% maximum of the 4 to 6% of pentane that is in the original.
So you'd work with the company to look at their whole process, all stages, and then figure out what technology.
I look at all the whole process. We look at it and then say, okay, how are we going to capture it? And then where are we going to send it to? Are we going to take that pentane? Because there have been, in the early days, where they tried to absorb the pentane and carbon. But what happens, as I said before, pentane is very explosive. It has a auto-ignition temperature about 450 degrees. It has a lower explosive limit of about 1.5, 15,000 ppm, that's 1.5%. So it is very flammable, and so putting it into a concentrator like carbon to absorb it, you are actually bringing the concentrations up way into the flammable or explosive level. And early in the 80s, people tried that and they've had explosions, etc. So after that, I got involved into this particular type of business in the 80s. So we said, no, this is not the way to go. So most of the time, you would put that into a regenerative thermal oxidizer, because the concentrations are low enough to do that, and you use very little fuel. But we have also put that into what they call direct fired incinerators, and then have used the pentane as part of the fuel for a boiler, because the process uses steam, to do all of this. But that part is not worth it unless they are a 24-hour, 7 days a week operation. Because when they are down, you still have to do the air pollution part, but you don't need the steam. So what do? So, it costs too much to do it that way as far as operations is concerned. So we put it to a regenerative thermal oxidizer, where we actually combust that. And in the regenerative thermal oxidizer, we return 95 to 97% of the heat that we use. So a burner is very, very small. Many cases, the burner can be even turned off and the thing can operate on the pollutant only.
So you would help. So after looking at the process, you'd figure out which technology makes sense for that company, and then you would build it here, ship and shore, and I guess have it installed on site. Do you help with the permitting process
Yes,
at all? And then,
of course.
Okay.
Because way in the beginning, when but again, because that's what we would have to do. We take a drawing like this, for instance, that we then send to the customer, but also discuss that with the air pollution people. I said, this is how we're going to do it. This is what we can do, and this is what we cannot do, the part that goes out, because many of the air pollution people, are unfamiliar as how. So we also try to educate the air pollution people. So we have given also little seminars for the engineers. We used to do that a lot many years ago. Lately no longer, since you have the computers. The engineers, at least the air pollution people, don't want that. So you wait until we get the permit to say, okay, they write the permit, and since we help doing that, or sometimes a consultant will do the permit writing, but we give all the information, the technical information, to the consultant, and then air pollution people send us a copy and says, okay, do you all agree with how we are going to do this as far as from the legal side? We say yes, okay, then we build and install and turn it on.
Yeah. And then after it turns on, and assuming everything is working properly, do companies typically take it from there, or do they typically rely on say you to monitor what's going on?
No, they will take it from there.
Okay.
The only thing what we do is we watch, because the air pollution people, there has to be a test done that everything that we said over here that would happen in reality. Mm-hmm. So a third party, which is totally independent, does the test and supplies that to the air pollution people. And then after that, we, depending on the customer, we supply the surface for the unit.
Okay. And by air pollution people, you mean like the South Coast AQMD?
Yeah, South Coast AQMD, right.
Okay, very good.
At one time, early in the, late 90s, early 2000, EPA got involved in that. So we worked a lot with EPA, and EPA depended also on us, like AQMD did, because we were to be known as the experts. That's why we have done about almost 90% of all the facilities in the United States. And even up to this day, when somebody builds a plant, they call us. Somehow I am the actually last person left of the experts, because we had about 4 experts. 2 of them passed away because they were in their 80s, and one is 94, is retired. And here I am, still working. I'm only 84, so.
Well, you still got a few more years left, I'm sure.
So I still have a few years left, yes.
So this actually leads us into the next question really well. And you've been in this field really since its infancy.
Yes.
And so I always love to talk to people who've seen the evolution of an entire field from beginning to current day. This is a very broad question. You can answer it however you like.
Sure.
But how has this field evolved from its early days till today?
Well, in the olden days, like I said, AQMD had 15 people, and they were in downtown Los Angeles together with the ARB, the
California Air Resources Board.
That is the state.
Yeah.
And EPA was formed, and they had their facilities in North Carolina. Of course, they had one in Washington, the main thing. But a lot of the work was done between North Carolina and people here, and people like us that actually were the people doing all the. In the beginning, it was all testing and testing. Mostly it was as ozone was the big thing. As probably you remember that, a school would close and you can't do this when ozone was higher than so many parts per million. And so the field, and the other thing was they were looking then at the power plants to begin with, the large power plants, looking at the manufacturing plants like reactors that they had, chemical plants. So they were starting to go after big industry first. And so personally, I did a lot of testing on the power plants here on the coast and on the coal-fired power plants back east. So, and all this testing, we did that and supplied that, of course, to the power company, but also worked with EPA, and here was AQMD, and came up, now, what can we do? How can we reduce like oxides of nitrogen, because that was one of the big things, was the acid rain. Mm-hmm. That's where they wanted to reduce that. And that also causes ozone when the reactors the sun and all of that.
Yeah, and particulate matter too.
Yes, particulate matter from the cars and on everything basically. So we did a lot of testing on the power plants and adjusting of burners, and we're doing things that nowadays are common, recirculation of reducing the oxygen in the air. We did water injection, steam injection, and to the power plants to get them down. And at that time, they were all burning gas and oil. So the oil was usually, the air pollution was about double of what it was with gas. So it was a very, very time of, like I say, a lot of testing, learning what was happening, because, like I said, we didn't know. There was nothing written that you could go after or do. And also work with the people from EPA, because EPA was overlooking everything. And you always had a kind of a rivalry between EPA and the state of California. The state of California, EPA says, okay, we should write these type of laws. State of California puts it a little bit stricter. State of California always was stricter. And wherever you go, even when we went into areas like in Europe, they say, where are you from? Southern California. Southern California, you know what you're doing. So that is the toughest job. If you are able to take care of things in Southern California, you can take care of all pollution problems. So this was, it was a very interesting time. Nowadays, you can read a lot about this, how to do certain things, and, so EPA is large, AQMD is large, where you have seen a new building there, and I've seen them go from one building to another. So
yeah, I think now they have many hundreds of employees, not just 15.
Yeah. I think it's more. I think they were talking about like 1,000 or 3,000 or something like that. Yeah, same with EPA. They're huge, because at that time it was very small. In North Carolina, they were in trailers.
So we are recording this in August of 2022, and we're coming out of the pandemic slowly.
Yes.
We're in the middle of the Omicron wave. We'll see how long this one lasts. Do you see any permanent changes to how you run operations here after the pandemic? For example, are people going to maybe have the option of working from home more? And looking even farther ahead, maybe some things that are not even pandemic related, what do you see as some of the interesting challenges over the next 10, 20, 30 years in this field?
Well, we definitely are living in a different world after the pandemic. And if we were to deny the existence of the hybrid work environment, and some people realize that they just don't ever want to go back to the office and working. I think that gave birth to being very creative and doing things differently. However, the nature of our business is such that we definitely do need to have our engineers look after their projects and be here in-house. I do see the ever increasing demand for our type of equipment and the industry because example, even though we're getting into electrical cars, even though we're getting into great technology that is coming online with respect to different types of growth we're having, but even manufacturing electric cars is going to require the car to be assembled and painted, and the batteries that are being used, eventually all of these batteries that they're not in use have to be recycled. So a recycled plant will have emissions. The painting operation will have emission. The types of paint they want to use, and some are very fancy and some are not, are going to have to go through spray booths and paints. So in my opinion, and I would like to be an optimist, if we want to keep breathing clean air and still be able to use a lot of our products the way we have and we work with, we still would need a lot of demand for pollution control and various ways of cleaning the air that we breathe. The ever increasing number of chip manufacturers that we have to have. So all of the chip manufacturers, no matter what, their facilities is going to require a pollution control system of some sort. So as a result, I think the industry is going to expand as we need more and we consume more. The only time I think I could confidently say we don't need it as much is we stop consuming. But I don't think that'll be the case. I don't know if I can have an economic forecast of what the consumer level would be in the next 10 or 20 years. But I think our industry would evolve as well. We're constantly looking at various ways of tackling the pollution problem. True, we address the air a lot, but we also are working with a lot of biofuel facilities now. That is another way of looking at clean energy, clean fuel, and so on. So that on its own would require us to be involved. And a lot more enforcement is coming about in areas where they had left off the idea of pollution. And one of which I like to mention is all the pollution that is created by all the vessels that are on waterways. And that hasn't been neglected, but there has not been as many solutions provided in order for them to be able to address it. But I'm very happy to say we were working with a team and we have probably one of the first one-of-a-kind type of systems that is addressing the pollution of all the vessels that are come and are sitting in the ports. And the ports are seriously looking at how do we control the pollution coming off of all the ports. And naturally, everyone knows California is the most aggressive in coming up with rules and regulations and enforcement. So as I said, as we produce more as various nations, we also need to address the pollution problem. And we're also tackling the pollution problem in locations like China that is extremely polluted. A lot of industry, as well as India, which is really strong in manufacturing, but also is beginning to address the pollution problem. And my last thing I like to add, I always say this, we do not have any geographic boundaries in the air. So whatever anyone does anywhere, it'll eventually travel to other parts. So if we like to have a clean planet, we need to all address it together.
I think there is a lot of stuff, although we're all talking about doing everything electric. However, like all your goods that are being shipped around worldwide are going ships. And ships are a lot of pollution goes on there. This is why right now This is what Anoosheh was mentioning. Yeah, we did pretty well, like the first system, that is to keep the ports clean. Because so when a ship goes into a port, it still needs electricity, so it runs all its auxiliary generators to generate that electricity. So, and that has to be taken care of. Of course, nobody looks at the, I should say nobody, but that's what they're looking at also, is of course the main engines, when it goes between port to port. And I was in Europe there, that was 2013, I think it was, and I was in Amsterdam. Amsterdam said, we want to be the first zero-emission port in the world. Well, right now, it looks like that Long Beach is the closest, being that, so a lot of that rules that have been now, and laws that have been written for California, Texas is looking very deeply into it, and actually the whole West Coast is looking into it. Yeah. So what will happen with airplanes? I don't know, because it's very hard to have equipment in the air, but of course the engines will have to be, probably improved all this time. So maybe they'll come up with electric, I don't know, because it's very possible. The possibility is always there. And not only that, I think though, when you are in this particular field, you learn a lot of other things that you can then move into. You see, like for instance, talking about the electrical, this is something that while you're in this air pollution field, you start finding out. You're working with companies that are making batteries and, other things. Say, hey, wait a minute, this seems to be a great field for me to jump into. It was just like in the olden days, when everything was space. Everybody wants to become a space engineer. And suddenly, here it stopped. So no more, hey, what do we do? Many of them went into the air pollution field.
I didn't realize that.
Yeah. So that is, that is one thing. So being in a certain type of industry in a certain field, if you're interested in it, always something will come up there. You can use your experience too.
Yeah, I mean, well, with like the regenerative thermal oxidizers, there's combustion involved.
That's right.
So anything that has a combustion, you will be much more.
You'll learn that, right?
How important is it to be professionally licensed in this field? So getting your PE license, and how important is it to get your, let's say, advanced degrees, like a master's degree or PhD? What kind of doors might that open?
It does, quite, having a PE helps, because many states say, well, we want to have the signature of APE. It doesn't matter how much you know, but it is a, legal thing. So it is always good to have a PE. To be advanced in it, yeah, I think that would be great, especially if you are very interested in research. If you want to research things, I think it is great to have a PhD.
Yeah, you almost have to.
Yes, absolutely. I mean, and it helps the whole industry, for you to know that. But, if you really want to learn more about a certain things, get your PhD. I don't have one, unfortunately. I was never good enough a student.
You've done quite well for yourself.
I've done okay, yes. I've done well for myself. But would it be nice, if I had a PhD? But,
well, I think it just also shows that, your degree will teach you only so much.
That's right.
But it's really, once you get into a field, it's really going to be your effort, your dedication
your effort, and your interest.
Yeah.
Look around, read a lot, find out tests that were done, that other people have done. So you really have to. This is where where you learn a lot. And don't be afraid to make your hands dirty, because what I have done, many times, because I don't do it anymore, but I go to the back, etc. I said, "Now this is how you do this," and you show somebody to do it. And, once they see that, and they see that that you are not dirty, that you sit there just with your nice, clean clothes, then that respect starts coming. And when you have that respect, the other thing what you also always should do, respect the other person. It doesn't matter of what part he is of the company, if he is the janitor or whatever. Always treat a person with respect. Respect to what he does. Learn from him. Because a lot of people you can learn from. You can learn from a painter. You say, what is painting? Oh, wait a minute. You got to stand exactly 13 inches from there. Yeah, but why not 12? Isn't it? No, 13 inches if you really get it. I didn't know that. You know what I mean? You can learn a lot from the people that are working under you. A company is people. We are a team. And you have to work as a team, regardless if you are CEO, engineering manager, vice president, welder, or whatever. You're all part of a team. Because if one of the team falls down, and I'm going to be even say it from, if the janitor does not clean the toilets, etc., people are going to be affected in their work. And then the whole company is affected. You see, the janitor? Yes, the janitor. So treat that janitor also right, because he's part of a team. It's a team effort.
Absolutely.
And always be part of a team. Many engineers like to hold their knowledge in their head because they are afraid of competition. But the thing is, what you do is teach other people as much as you can, because if you want to go ahead in a company, you got to have somebody that can take your place. You don't want to be the one that, if we lose him, the company is gone.
So if a student right now is listening in high school or college, and they love what you both have been talking about, they're interested in getting involved in this field of air pollution control, what recommendations would you give so that they could be better prepared to enter this field, and how could they get a foothold in this field?
Well, one of the things that I'm very happy to see, as I have a son that is beginning to start college this fall, is that environmental studies are becoming a major prominent area where students can really focus. And social sciences in some ways are beginning to find their way into addressing some of these other issues that we have at hand that we're dealing with. The medical industry is looking at the problems we have created in terms of pollution that is causing asthma. So if someone is thinking consciously about what could I do and what could I study and how can I become effective in making sure I serve not only their own passion, as well as being effective and fruitful for next generations to come, there are ways. And as long as they don't take their eyes off of the importance of the issue, they can always, even in the field of law, environmental law is becoming very prominent because there's just a lot of issues that are rising and people have to address it. So if students really like to pay attention to this aspect of where we could go and what we could do with the environmental studies and the pollution control, I think it all sort of eventually connects together. And as you mentioned, there are a lot of universities that are taking students that like to do a lot of research on potential possibilities. The nanotechnology was trying to address some of the pollution at one point in time. Building new filtration systems that never ever looked at it as carefully and in detail as to how do we address the pollution and how do we perhaps install filtration system where it can get rid of the particulate matters, PM, that is going out in the atmosphere. Nowadays, we're finding out a lot of major food manufacturing facilities that do a lot of fried food just on major scale are having to address this because a lot of the oil droplets are beginning to really cause that PM problem as well as some of the pollution. So if students have the desire to remain in the field, there's just a lot of different studies they can go into, but this would be a good platform and underlying avenue and discipline of study. So that's what I think.
All right, thank you. I'll let you get to your phone call now. And at this point in the conversation, Anoosheh and John had to take a call with the customer, but we said our goodbyes off the air. I would like to again thank Anoosheh and John for sharing their experiences about what it's like to work in this field of air pollution abatement. In case you're interested in learning more about the company, in the show notes, I've included a description of Ship and Shore Environmental along with a link to the company's website. Well, before I go, I would like to mention that if you're enjoying this podcast, there are a few ways to support it. You can subscribe to the podcast using your favorite podcast app, such as Apple Podcasts, Stitcher, Google Play Music, Spotify, and many others. You can rate the podcast and leave comments on whatever app you use to listen to the podcast. And finally, you can help spread the word about the podcast by telling your friends and family and anyone else you think might be interested in this podcast. If you have any comments about the episode, feel free to email me at tesepodcast@gmail.com, and I'll place the email address in the show notes. I will personally read each email and try my best to respond to them all. Take care, everyone, and goodbye for now.